Okay, so now basically in order to the next question that we have, we want to find the derivative of these functions. For example, let's say that you have the f of x is equal to basically sine x is equal to sine x cos x. So we can use the Leibniz product rule, which is u times v whole prime is equal to u prime times v plus u times v prime. So then basically the derivative of this function is going to be equal to f of f prime of x, which is equal to d by dx of sine x times cos x plus basically sine x times the derivative of cos x. Now the derivative of sine x is equal to cos x, so basically d by dx of sine x is equal to cos x, and d by dx of cos x is equal to minus negative sine x. So you can write this as cos x times cos x plus sine x times negative sine x plus negative sine x, which is equal to cos squared x minus sine squared x. Now if you remember cos squared x minus sine squared x, you can write this as, also you can write it as cos of 2x. So that means that d by dx of sine x cos x is equal to cos 2x. Or you can write it as cos squared x minus sine squared x. That's basically the same thing. 11 cos of 2x. Remember, the next one, for example, is secant x. d by dx of secant x. I suppose we have this already, although I don't remember really. d by dx of tan x we already did. Okay, so let me write down the derivative of these functions, what we have found so far, because we are going to need them. So basically the derivative of d by dx of sine x is equal to cos x. Now d by dx of cos x is equal to negative sine x. d by dx of tan x is equal to, well, basically 1 minus is equal to secant squared x. That's what we had so far. And there was something else as well, d by dx of, which is not really very relevant here, but d by dx of sine squared x, for example, is equal to sine 2x, meaning that is equal to sine 2x basically. Now if you have the d by dx of basically secant x, we haven't calculated that yet, so we will need to use the first principle in order to calculate that. Okay, so now let's see what we can do with secant x. It must be a little bit of trouble really, because so now if f of x is equal to secant x is equal to secant x then well, you know that basically then f of, if you want to use the first principle, then f prime of x would be equal to the limit of f of x plus h minus f of x over h as h tends to 0. So now f of x plus h in this case is equal to secant x plus h. Secant x plus h, and so then this becomes the limit of basically the limit of secant x plus h minus secant x over h as h tends to 0. And now the problem is that we don't have any formulas for example, something like secant, for example, x minus secant y. We don't have that. So I suppose what we can do, I really don't know if that's going to work, but that's worth a try. So I can write this as the limit of, well, you know that secant x is 1 over cos x. So that's basically 1 over cos x plus h minus basically 1 over cos x over h as h tends to 0. And now if I take the LCM over here as cos of x plus h times cos x, and then the numerator becomes basically cos x minus cos of x plus h, and the whole thing is divided by h as h tends to 0. And then cos of x minus cos y, cos x minus cos y is equal to negative 2 times sine x plus y divided by 2 sine x minus y divided by 2. So I can write this part as the limit of basically negative 2 times sine x plus y divided by 2. I'm sorry, not x plus y divided by 2, but you have to basically x plus y here becomes x plus y divided by 2 becomes x plus h divided by 2, which is equal to 2x plus h divided by 2. So that's 2x plus h divided by 2. And then you have sine of x minus y divided by 2. So sine of x minus y is x minus h divided by 2, which is equal to, so these two will cancel out. That's negative h divided by 2. Now sine of negative h divided by 2 is equal to negative sine of h divided by 2. I write it as negative sine h divided by 2 divided by, and that must be divided by basically cos x plus h times cos x over h as h tends to 0. And so what that means is that so now your goal is to somehow get rid of this h over here. So if you had, for example, something like, and if you multiply this negative sign with this negative sign, these two will cancel out. And so if you had, for example, a over b, this divided by c, which is h here, that would be a divided by b times I don't know what this is. So then you would have a divided by b times 1 divided by c, which is a divided by b times c. A divided by b times c. So that means that I could write this as limit of basically a, which is 2 times sine 2x plus h divided by 2 times sine of h divided by 2 divided by b times c. So that would be basically cos of x plus h times cos of x times h, and then as h tends to 0, and so then you could write this as the limit of sine of h divided by 2 divided by h divided by 2. This 2 comes to the denominator and this becomes h divided by 2 as h tends to 0, and this becomes a 1. And then you have also basically you have basically over here you have the sine of, or let me write the limit as this way. So the limit of basically sine 2x plus h divided by 2, 2x plus h divided by 2 over basically this whole thing, cos of x plus h times cos of x as h tends to 0. So then now this part becomes 1, and if you have basically if h tends to 0, then this part over here in the numerator, of course you can separate these. You can write this as the limit of this divided by the product of the limits of these two, but then you can of course do it directly as well, meaning that you can write it as basically sine of, if h tends to 0, you'll get sine of 2x by x, which is equal to sine of x. And if h tends to 0 here, you'll get this cos of x, and this is basically cos of x. So you'll get sine x divided by cos squared x, which is equal to tan x times cos x. Now, depending on, I don't know how they actually write this. I actually have forgotten that. Which part is this? Secant x number 2, part 2. Secant x tan x. Okay, so you can write this as, tan x, basically. Sin x by cos x is tan x, and then over here you have 1 over cos x. So I can write this 1 over cos x is equal to secant x. So I can write it as secant x tan x. We can write it as secant x tan x. So that means that basically when you have the limit of, I'm sorry, not the limit, but the derivative of secant x, when you have the derivative d by dx of secant x is equal to secant x tan x. So that is basically one more thing that we can add over here. I could probably make a screenshot of this. Okay, I'll write it down somewhere somewhere else, and then we'll make a screenshot of this, because I need to close this page and then we will lose everything that way. Okay, so basically we said that d by dx of sin x is equal to cos x. D by dx of cos x is equal to negative sin x. D by dx of tan x is equal to what? I think it was secant x. Tan x is equal to secant squared x, and sine squared x, let me write these down over here. So d by dx of tan x, d by dx of tan x is equal to secant squared x, and d by dx of sine squared x is equal to sine 2x. And then down here we had something else, d by dx of secant x is equal to secant x tan x. So now I go over there and write these down on the other. Okay, so d by dx of tan x is equal to now secant squared x. Secant squared x, d by dx of, for example, I don't know, d by dx of sine squared x is equal to sine 2x, and d by dx of secant x, d by dx of secant x is equal to secant x tan x. Secant x tan x. Okay, I'll make a screenshot here and then we will go to the next problem. What is that? Why is it not working? For whatever reason this is not working. Let's see. Okay. We call it, for example, trigonometry. Basically differentiation. application 1, save it on desktop, and now we can go and solve the second problem. Okay, so now suppose that you have, for example, you want to find the derivative of some function 5 secant x. You have the derivative, you want your function is f of x is equal to 5 times secant x plus 4 times cos x plus 4 times cos x. Now, if d by dx of f of x is equal to d by dx of 5 times secant x plus 4 times cos x, which is the same thing as d by dx of 5 times secant x plus d by dx of 4 times cos x. Now, when you have basically, if you want to find the derivative of these two functions, these two functions multiplied together, you can see this as a constant function. So when you want to find the derivative of this function, let me stop this for you. Okay, so when you have two functions like this, for example, when you want to find the derivative of d by dx of, for example, 5 times secant x, so based on the Leibniz product rule, you said that u times v whole prime is equal to u prime that point times v plus u times v prime. So the derivative of the first function is always 0 because it's a constant function. So you will end up with the second function, with the second part, which is basically the first function times the derivative of the second function. So you will basically end up with we will end up with 5 times the derivative of secant x, which is we just said that the derivative of secant x is the derivative of secant x is secant x tan x. Is secant x tan x. So you have 5 times secant x tan x. So this part over here is 5 times secant x tan x. And this part over here, you have derivative of cos x is negative sin x. So plus negative 4 times sin x. So that's equal to 5 times secant x tan x minus 4 times sin x minus 4 times sin x. So that is the derivative of this function over here. For example, part 3, 5 times secant x tan x minus 4 times sin x. Now suppose that you have the derivative, you want to find the derivative of, for example, cosecant x. This again you need to calculate based on the first principle. So if y or if f of x is equal to cosecant x is equal to cosecant x, then we said that f prime of x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. So that is equal to, so then the f of basically x plus h in this case is equal to cosecant of x plus h. So then this becomes the limit of basically cosecant x plus h minus cosecant x over h as h tends to 0. And since we don't have, basically we don't have any formulas for cosecant, for example for something like cosecant x minus, for example, cosecant y, we need to make some changes to the numerator. And you make those changes by limit of, for example, you know that basically cosecant x is equal to 1 over sine x. So I can write this as 1 over sine x plus h minus 1 over sine x over h as h tends to 0. And then you can write this as the limit of basically sine x plus h times sine x, and there you have sine x minus sine x plus h over h as h tends to 0, which is equal to now you know that sine x minus sine y, as we discussed before, is equal to sine x minus sine y, as we discussed before, is equal to 2 times cos x plus y divided by 2 sine x minus y divided by 2. Okay, so then I can write this as the limit of 2 times cos, so x plus y divided by 2 would be x plus h divided by 2, which is 2x plus h divided by 2. 2x plus h divided by 2. And then you have the sine of x minus y divided by 2, which is x minus x plus h divided by 2, which is equal to x minus h divided by 2. And then you have, and then you can cancel these two out. You have negative h by 2. Now sine of negative h by 2 is equal to negative sine h by 2. So I can write this as negative sine h divided by 2 over sine x plus h times sine x divided by h as h tends to 0. As h tends to 0. And then you can write this as the limit of 2 times cos 2x plus h divided by 2, and the negative I can put it over here, and then I can take it out but not now, sine h divided by 2 divided by sine of x plus h times sine of x times h as h tends to 0. And then I can write this as the limit of sine h divided by 2, and take this h and this 2 and write it as h divided by 2 in the denominator, and take this negative, I can take it out, and then over here I can write cos of 2x plus h divided by 2 over sine x plus h times sine of x times sine of x. Well, of course I should have written it a little bit differently, but that doesn't matter really. So then I can write this as the negative limit of basically sine h divided by 2 over h divided by 2 as h tends to 0 times the limit of basically cos 2x plus h over 2 divided by sine x plus h times sine x as h tends to 0. Now this whole thing over here is 1. This whole thing over here is 1. So you'll get negative 1 times, so when h tends to 0, this becomes cos of 2x by 2, which is basically cos of x. This becomes sine of x, and this is sine of x. So then you have basically negative of cos x by sine x is equal to cot x. 1 divided by sine x is equal to cosecant x. So that means that the derivative of cosecant x is equal to negative cosecant x, negative cosecant x, cot x. That is basically that is one another part of those formulas that we were looking for. So now so far we have d by dx of sine x, cos x, tan x, secant x, cosecant x. I don't know what we have really. Let's see. We have sine x, cos x, tan x, secant x, also cosecant x. Let me see if I can write over. I can't write over here. Delete. Burn, open, and paint. And then I can write d by dx of cosecant x is equal to negative cosecant x cot x. Negative cosecant x cot x. And then if I save it, I suppose now if I open the same file, I will get that file edited. Yes, the file has been edited. So now we have the formula for sine x, cos x. There's supposed to be x over here, tan x, secant x, cosecant x. The only thing that remains is sine, cos, tan, cot. The cot is missing. You need to find that too. Okay. So let's go over here and see what's left here. If cot is not there, we will add it to the list. I mean, it's at least not in these exercises, but we will add it to the list as we go on. Okay, so now suppose that you want to find the derivative if your x is equal to f of x is equal to 3 times cot x is equal to 3 times cot x plus 5 times cosecant x. But I suppose we don't have the derivative of cot x here. Now cot we haven't calculated. So let's go and calculate the derivative of cot x first, and then we will use it over here. So now suppose that your f of x is equal to basically cot x. Then assuming that, and that's a safe assumption to make, that f prime of x is equal to the limit of f of x plus h minus f of x over h as h tends to 0, then f of x plus h is equal to cot of x plus h. So then f prime of x is going to be equal to the limit of cot of x plus h minus cot of x over h as h tends to 0. Okay, so now since the formulas that we have are only in terms of basically in terms of cos and sine, meaning that we have all that we have is basically cos x basically plus cos y and cos x minus cos y, and we have sin x plus sin y, and we have sin x minus sin y. Then we need to express cot in terms of cos and sine. Now I can write this as the limit of basically, you know that cos x is equal to, cot x is equal to cos x divided by sin x. So this is basically, this is cos x plus h divided by sin x plus h minus cos x by sin x divided by h as h tends to 0, and that is equal to the limit of sin x plus h times sin x, and then you have sin x cos x plus h minus cos x times sin x plus h divided by h as h tends to 0. And then what you can do is that can do is that we have sine x plus h times sine x. Sine x plus h times sine x. Okay, so let me take a look at this thing. Let me see how we can simplify it. Okay, so the way that you can simplify this thing is that basically in the trigonometry formulas that I showed you, I don't know if it was in this video or in the previous video, we said that sine x minus y, is equal to sine x cos y, minus cos x sine y. And if you look at this expression over here, it's exactly the same thing, meaning that you have sine x cos x plus h minus cos x sine x plus h. So that's basically, this is, you have x over here, x plus h over here, x plus h over here. These are the same angles, and this is sine times cos, this is cos times sine, and you have negative sine over here. The exact same formula. So this is equal to sine of x minus y. So you can write this numerator as sine of x minus y. X over here is x, and y is x plus h, which is equal to the sine of x minus h, which is equal to sine of negative h, which is equal to negative sine h. So I can write this as the limit of negative sine h, and then you can rearrange this fraction and basically take this to the denominator and write it as sine x plus h times sine x times h. And the reason why you can do that is that you know that if you have a divided by b and divide that by c, this is a divided by b and this is c, that is going to be equal to a divided by b times 1 divided by c, which is equal to a divided by b times c. A divided by b times c. So this is now a, which is basically this expression rewritten and as we talked about it, and this over here is b times c. I have written everything in the denominator. And so I can, as h tends to 0, sine x times h. So this is that. So I can take this negative sign out, write this as the negative limit of sine h divided by h as h tends to 0 times the limit of, so these two are taken care of, and then I have the limit of 1 over sine x plus h times sine x as h tends to 0. So this part, as you know, is equal to 1. So you have negative 1 times, now over here when h tends to 0, this is sine x and this is also sine x, so this is 1 over sine squared x. So 1 over sine squared x is equal to cos squared x. This is cos squared x, so that's negative cos squared 1 over sine squared x, I'm sorry, it's cosecant squared x, so that's negative cosecant squared x. So that means that the derivative of cot x is equal to, that means that d by dx of cot x is equal to negative cosecant squared x. That is basically this part, and now we can use it in our result. So I open this in Paint, for example, and d by dx of cot x is equal to cosecant squared x, of course negative cosecant squared x. So that is that. So now I can go over here, and then we can now solve the problem that we have. 363. Okay, so now in order to calculate, for example, if your f of x is equal to 3 times cot x plus 5 times cosecant x. Now d by dx of f of x is equal to d by dx of 3 times cot x plus 5 times cosecant x, which is equal to d by dx of 3 times cot x plus d by dx of 5 times cosecant x. Now we said about these, basically we said about these functions, for example, d by dx of 3 times cot x, we said that when you have these, basically these two functions u and v multiplied together, if you want to take the derivative of that, if the first function is basically a constant, then you will, normally you have this as u prime times v plus u times v prime. But then since the first, basically the first function is a constant function, and it will be, the derivative of that function is 0, and this part is 0, and you get only the second part. So then this is going to be 3 times basically the derivative of cot x. Now we said that the derivative of cot x is equal to negative cosecant squared x. So negative 3 times cosecant squared x. So this is negative 3 times cosecant squared x, and also the derivative of 5 times cosecant x. The derivative of cosecant x is minus cosecant x cot x. So negative 5 times cosecant x, negative 5 times cosecant x cot x, which you can write as, for example, I don't know, you can write it in any way that you want. Part 5 is negative 3 cosecant squared x minus 5 times cosecant x cot x. That's basically the answer. Now, for example, let's say you have this function over here, 5 times sine x. F of x is equal to 5 times sine x minus 6 times cos x plus 7 So d by dx of f of x is equal to d by dx of 5 times sine x minus 6 times cos x plus 7, which is the same thing as d by dx of 5 times sine x minus d by dx of 6 times cos x plus d by dx of 7. So d by dx of sine x is cos x, so this becomes 5 times cos x. D by dx of cos x is equal to negative sine x. Negative into negative is positive, so plus 6 times sine x. And d by dx of 7 is equal to 0. So that is your answer there. Part 6 is 5 cos x plus 6 times sine x. Or suppose that you have, for example, you have f of x is equal to 2 times tan x minus 7 times secant x. Now the derivative of basically we said that d by dx of tan x is equal to secant squared x, or d by dx of secant x is equal to secant x tan x. Secant x tan x. Now about this function, you can write d by dx of f of x is equal to d by dx of 2 times tan x minus 7 times secant x, which is equal to d by dx of 2 times tan x minus d by dx of 7 times secant x, which is equal to tan x would be secant squared x, so 2 times secant squared x minus secant x is secant x tan x, so 7 times secant x tan x. That's how you, for example, can calculate the derivative of this function, 2 secant squared x minus 7 secant x tan x. Okay. So in the next video we will talk a little bit about the miscellaneous examples that we have in this chapter. We have a couple of miscellaneous examples. And then after that we have a couple of miscellaneous exercises, and that's the end of this chapter. So I'll see you in the next video. Thank you.